For your test on Tuesday, okay, let's start with vocab. There were a lot of definitions that we covered in this unit, so so there are quite a few of them for you to look over. First, obviously you need to know what a matrix is. This is the very first one we'll talk about. You have to know what a matrix is. You have to know what an element is. And then we talked about the 5 different types of matrices: row matrix, column matrix, square matrix, identity matrix, and the zero matrix. Okay, you need to know what those are. You need to know what a matrix equation is, and then as well as you need to know what an inverse is. An inverse matrix, I should say. Last couple things you need to know are non-singular matrices and singular matrices, especially when you know the difference between the two. Okay, so that's about 11 terms for you guys to look over. And you're essentially going to have 3 sections on the test. I worked really hard to make sure that everything fits on one page back and front. So you're only going to have 3 sections for this test. First section will be all 4 matrix operations: addition, subtraction, scalar multiplication, and matrix multiplication. The second section will be determinants and inverses. The last section will be solving systems of equations using matrices. and throughout this section, you will see both 2x2 matrices and 3x3 matrices. Okay, and I will allow you to use your calculator for this test. Okay, so just to make sure that we're clear on that. Let's start with this section here. I have 3 matrices, A, B, and C. Okay, let's start with the first problem, A plus B. Okay, on this test, the first thing that you should always check to see is if you can actually do the operations that it's telling you to do. So up here, for example, can I add A plus B? Why can I add A plus B? They have the same dimensions. Addition and subtraction, even scalar multiplication, they have to have the same dimensions. Okay? Well, I'll get to that in a minute. So A and B are both 2x2 matrices, so we can go ahead and add them. All right? If I'm adding them together, and they're both 2x2 matrices, what are the dimensions of my answer going to be? Good, Donnie. Yes, 2x2. For addition and subtraction, you do not change the dimensions. The only time that you change the dimensions is for matrix multiplication. Okay? And so, since these two are 2x2 matrices, then A plus B is also going to be a 2x2 matrix. 2x2 matrix. And so again, you're either adding or subtracting each pair in the same spot. Okay? So that's what we're going to do for this one. So that's 2 plus 2. That's 4. Negative 5 plus negative 4. Negative 9. Negative 1 plus negative 1. Negative 2. And 3 plus 2, 5. That's it. Simple as that. Okay? All right. Look at number 2. Look at number 2. Can I subtract B minus C? Can I do B minus C? No, why not? They don't have the same dimensions. So what do I put down for this? Well, if an operation is not defined, then you make sure to let me know that it's undefined. Okay? You don't have to explain why. Just let me know if it's undefined. I need you to tell me that it's undefined. Okay? Look at number 3. 2b minus 3a. Can I do that subtraction? Can I do 2b minus 3a? Yes, b and a have the same dimensions, just like the first one. Even though it's scalar multiplication, I can still do that subtraction. Okay? So that's 2 times this matrix. So 2 times 2, negative 4, negative 1 and 2, minus 3 times this matrix. 2, negative 5, negative 1, and 3. Now, I would recommend doing the scalar multiplication first before doing the subtraction. Okay, because remember, it's order of operations. It works pretty much the same as you know, if you were like evaluating real number expressions. Okay, when I distribute this here, leave the minus sign where it is. Don't distribute -3. Distribute the +3. Okay, because I don't want you to get your signs mixed up and then have your entire problem be off by the sign of one value. Okay, so we're going to do the scalar multiplication first, which means taking each constant here and distributing it into each part of the matrix that they're next to. Okay, so that's 2 times 2, which is 4, 2 times -4, which is -8, 2 times -1, which is -2, and then 2 times 2, which is 4. Minus 3 times 2, which is 6, 3 times -5, which is -15, 3 times -1, which is -3, 3 times 3, which is 9. Okay, and now we can go ahead and do our subtraction. 4 minus 6 is -2. -8 minus -15 is 7. -2 minus -3 is 1. And then 4 minus 9 is -5. And wherever you can, try to circle. Make sure you circle your final answer so I can see where your answer is. Because I don't have blanks in every problem. So for ones that you don't see blanks for, just make sure you circle your final answer. Okay. Then we get to matrix multiplication. Okay. B times C. All right. Again, let's check the dimensions. B is a 2 by 2. C is a 1 by 2. Can I multiply those two together? Mara, why can't I multiply those two together? Well, like you said no, right? Why can't I multiply those together? Exactly, that's right. Good job. Yeah. The number of columns here has to match the number of rows here. The inner dimensions have to match. So these two don't match. I can't multiply it. That's also undefined. Now, let's say I was doing C times B. Can I multiply C times B? Let's see. C is a 1 by 2. B is a 2 by 2. Looks like these two match. I can go ahead and multiply them. Okay? So that's 1, 2 times 2, -4, -1, and 2. Now, if these two match, what is going to be the dimensions of my product? Good. 1 by 2, the outer dimensions. 1 row, 2 columns. Okay? All right, so for each multiplication, we're going to use this row. And then first column, we'll use this column. Second column, we'll use this column. Okay? Because remember, with each place that you're filling in, you're using the row from the first matrix and the column from the second matrix. Okay? So first row, first column, that's this right here times this. Okay? So that's 1 times 2, which is 2. 2 times -1, which is -2. So 2 plus -2, which is 0. And then second column, this 1 times -4 is -4. 2 times 2 is +4. So -4 plus 4 is 0. Okay. Now, I don't think you'll come across answers like these on the test, but if by some chance you do, you can also write this as 0 because it's a 0 matrix. It has only zeros in it. Okay, that's the only exception to, like, if, for example, I couldn't do this if both of these were 1s or both of these were 2s. Okay, this is the only matrix that you can do this for, is the 0 matrix. Okay. Now, you don't have to, but, you can if you want to. Any questions with this section before I move on to the next one? All right, then let's move on. Next, here's my matrix A. We're going to look for the determinant. We're going to determine if it's non-singular, and we're going to determine if it has an inverse. Okay? Before I get into that, another thing that you're going to need to know before I forget, you're going to have to you're going to have to know how to tell if two matrices are inverses of each other. How do I know if two matrices are inverses of each other? The same determinant? Not exactly. Yes, Mara. Okay, if you multiply them together, then what? Almost. Not one. Yes, good, thank you. Yes. When you multiply them together both ways, not just one way, if you multiply them both ways, and I get the identity matrix, that's how you know that they're inverses of each other. So for 2 by 2s, the identity looks like this. For 3 by 3s, the identity looks like this. When I multiply either 2 by 2 matrices or 3 by 3 matrices together, I multiply them both ways, and I get either one of these, then those two matrices are inverses of each other. So please make sure that you remember that, because that may come up during the test. Okay. Now, anyways, let's get to here. Determinant of A. So this is a 2 by 2 matrix, so determinants is pretty easy to find. If you're trying to find the determinant of a 3 by 3 matrix, you can either do that by hand or you can do that in the calculator. I'll show you that on the last problem. Okay, so for a determinant, you cross multiply and subtract. So this times this minus this times this. Okay, so 2 times 4, that's 8. -1 times -7, that's positive 7. So 8 minus 7, that's 1. Okay. Which leads me to the next question. Is A non-singular? Is A non-singular? You don't think so? Why not, Daddy?
Wait.
Yes. So, is your answer yes or no? Somebody help him out. Somebody help him out. Yes. Why, Chloe?
It's only singular if it equals 0, and since it equals 1, it's not.
Thank you. Yes, exactly. Great job. Yes. The determinant, in order for a matrix to be non-singular, the determinant has to be anything but 0. If your determinant is 0, then it is singular. It is not non-singular. So here my determinant is 1. It's not 0. So is it singular? Yes, A is singular, which means I can find its inverse. Again, for 2 by 2 matrices, if you're looking for the inverse, you can either do that by hand or you can do it by calculator. If you're going to do it by hand, remember, the formula for that is 1 over the determinant times this matrix. So you would switch these two elements and then change the sign of these two elements, okay? So in this case, my determinant was 1. All right, I'm going to switch the 4 and the 2, and I'm going to change the sign to the negative, from the -1 to the negative. I'm going to change the signs on the -1 and the -7. So it's going to be +1 and +7. Now, this is just going to be 1, and 1 times anything is itself. So my inverse is this matrix, 4, 7, 1, 2. Now, if you want to check it, you can, and if you have the time for it, you can multiply and both ways to see if they get the identity. But you can do that on your own for this one if you want. Okay. Now, let's suppose that my matrix had a determinant of 0, which means that it's not non-singular. Well, I can't calculate the inverse, so what am I going to put for that? All you have to tell me is just doesn't exist. Okay, D and E does not exist. That's only if your determinant is 0, because that means that it's not non-singular. It doesn't have an inverse. Okay, so that's your other option. All right. Any questions about this before I move on to the last section. Alrighty then let's move on. Last section. Solve using matrices. So originally, this is what the equation looked like here. This is what the equation originally looked like. The reason why I put zeros there is because if you're going to put this in matrix form, you have to make sure that every variable is accounted for. See, the first row has an x, a y, and a z. The second row does not, so I have to put a 0 in its place. Same thing here. There's no x here, so I have to put a 0x in its place. That way, I'll know exactly what coefficients to put there. When we solve systems of equations using matrices, that's where we split our system up into 3 different matrices. One for our coefficients, one for our variables, and one for our constants. Okay? So, my variable matrix, my coefficient matrix, 1, 1, 1, 4, 5, 0, 0, 1, negative 3. Okay? Then I have my 3 variables, x, y, and z. And then I have my coefficients. My constants. 4, 4, negative 9. Excuse me. All right. Before I solve this, because I'm going to need inverse matrices to solve this, I need to make sure that my coefficient matrix has an inverse. Okay? So again, you can either do this by hand or you can do it on your calculator. If you're going to do it by hand, here's how to do it. So if you're going to do it by hand, what you want to do is you want to copy the first 2 columns on the side here. Okay? Then we'll do our cross multiplication. This product plus this product plus this product minus this product plus this product plus this product. Okay? So this one, 1 times 5 is 5. 5 times negative 3 is negative 15. 1 times 0 times 0 is 0. 1 times 4 is 4, and 4 times 1 is also 4. Minus 0 times 5 times 1 is 0. 1 times 0 times 1 is also 0. Negative 3 times 4 is negative 12. Negative 12 times 1 is also negative 12. Okay, so that's negative 15 minus negative 12. That's negative 3. Oh, I'm sorry. Let's rewind. Thank you for catching that. Negative 15 plus 4 is negative 11. So negative 11 minus negative 12, that's 1. So my determinant is non-zero. That means it is going to have an inverse. Okay. When I solve this matrix equation, remember, I cannot divide matrices. But what I can do is I can multiply both sides by the inverse of this. Be aware, because I'm multiplying the inverse on the left side of this matrix, I also have to multiply the inverse on the left side of this matrix. Because if I try to do it on the right side, the multiplication is not going to be defined. Okay? Because remember, this is a 3 by 3. This is a 3 by 1. The only way that I can multiply the inverse with this matrix is on the left side because the inner dimensions match. If it was on the other side, they wouldn't match. Okay? So that's why I'm doing it on the left side here and on the left side here. Okay? So whatever my inverse is, that's going to be multiplied by this. by my constant matrix. Okay? And if you're doing this in a calculator, if this is your A and this is your B, then it should look like this when you put it in a calculator. Okay? Now, just a sidebar here. If this were a system of two variables, x and y, that would mean you would have a 2 by 2 matrix to work with. You can also do the inverse by hand, if that's easier for you. But for 3 by 3s like this, you are going to need a calculator for this. Okay? Specifically, you're going to need one of these. Because again, if you don't have one of these, you need to go ahead and get them. Right? All right, so let's go ahead and put that into the calculator. I've already have my matrices set up here. So I'm just going to go ahead and press enter, and there's my solution right here. One, 0, 3. Now, because we're doing a system of equations, just like on that last test with systems of equations, I'm going to ask you to write your answer as either an ordered pair or an ordered triplet. Okay? This is in 3, so we're going to write our answer as 1, 0, 3. Okay. Now the good news is I'm not going to ask you what type of system it is. Any problems like this that you'll see up there will have a solution. So you don't have to worry about a system having infinite solutions or not having any solutions at all. Okay? Every problem that's in that section will have a solution to it.